the same student are leaving, Aromantic is disconnecting the record. So I activate the record, and I deactivate the record. Okay? Okay. Now, the rest is x squared minus 5 equal to 0, ¿no? Es obvio que x is equal 0. Multiplicity 4. That's mean que 0 is repeated 4 times. 0, 0, 0, 0. Of course, you write only one because it's the same value. And this is a quadratic equation, and you solve that. And this is square equal 5, square root both sides. X is equal plus or minus radical 5. Okay, entonces, si you listing the 0, in this case, multiplicity 1, ¿no? Because, bueno, es, okay, basically is 0 multiplicity 4. Radical 5 multiplicity 1, ¿no? And negative radical 5 multiplicity 1. Entonces, when the multiplicity is even number, touch. When the multiplicity is odd number, cross the x. Entonces, what do you suppose is the option que you select? Let me see. I suppose que es option C, ¿no? Okay. Y option B is the same. Stupid thing. Or no? Es B or is C? What do you think? I don't see the difference. Tell me. It's the same, right? Remember, our test is no multiple choice. Our test is no multiple choice. Okay, one more interesting thing. Let me try to do the sketch, roughly sketch, about the graphic of this polynomial. Suppose the end behavior expression is, I come back at the beginning. At the beginning is 1/3. Entonces es x to the 4 power. X to the 4 power. And this is x to the second power. No? X to the second power because I ignore this 5 and the end behavior. Entonces this is 1/3 x to the 6th power. Yeah, I know that the end behavior look like that because the exponent is even, number 1, and number 2, the coefficient is positive. So the end behavior look like that. But we have 3 0. 1 is 0, 1 in radical 5 positive, and 1 in negative radical 5. So I suppose, using my common sense, that the graph look like a cross, touch, and cross. Something like that. Okay, this is the geometric interpretation for this idea. Maybe it's no too clear, but now in the graphic part, in my opinion, is super clear. Any question, guy? It's clear. Okay, Yasmin. Okay. Okay. How do you know the graph went up? So I need to know, looking the end behavior expression, que es this. Que when exponent is even and the coefficient is positive, this look like that. I don't care what happened in the middle. Okay? If this is even, coefficient is positive, exponent even, you know? When the exponent is even also, where the coefficient is minus, entonces it's something like that. It's like a reflection, no? Okay, do you remember, right? Wait, let me finish. You asked me, I try to answer everything. See, the exponent is odd, and the coefficient is positive. Look like that. See, the exponent is odd, and the coefficient is negative, it's something like that. Okay. So in our example, is this corresponding with the exponent even of the end behavior expression, que is 6. And coefficient is positive because for positive 1/3. So I know that my graph ending end behavior like that. Entonces the rest, bueno, okay, roughly, no exactly, but es 0 en radical 5 negative, 0 en 0, y es 0 en positive radical 5. Y I know que in the multiplicity 1, cross it, like that, cross it, y en multiplicity 2, 4 in this case, que es even, touch. Any question? Any question? No? Okay, let's move on to the question 2, que es similar. Question 2 is similar. Look, question 2 is. Okay, question 2 is f of x again, the same name. 1/2 x to the 4th power, parenthesis, x squared minus 5, x minus 2. Okay. Entonces you put equal to 0. You ignore temporarily this 1/2. And therefore, x to the 4th power is equal to 0. That means x equals 0 multiplicity 4 again. And now the graph touch on x-axis. Likewise, this is similar. X squared minus 5 equal to 0. We have two solutions, no? In positive radical 5 and negative radical 5. No? In both cases, the multiplicity is 1. Now cross. And finally, x minus 2 equal to 0. X equal positive 2. Of course, multiplicity 1 because we have no exponent. No? And this is cross. X. To complement this idea. Well, okay. What is the answer, guys? What is the answer? The answer is A, B, C, or D. What do you think? Suppose que es 0, 2, multiplicity 4, 2 multiplicity 1. I suppose que es C, ¿no? Pero, and D is incorrect, or let's say, no. Because D make a mistake, cross or touch. Okay, es option C, ¿no? Es option C. Are you agree or disagree? Okay, just in case, to make sure, let's do in the graph. This is my all real number line. Positive infinity, negative infinity. Okay, let me try to understand a behavior expression. And behavior expression. And behavior expression is 1/2 x to the 4th power, x to the 2nd power, and x to the 1 power. So I ignore in the end behavior this 5 and this 2 because it's totally negligible. Therefore, the end behavior expression is 1/2 x to the 7th power. Yeah, I know. See, the exponent is odd and the coefficient is positive. The end behavior look like that. Entonces we discover that we have in total 0 touch radical 5. Radical 5, suppose radical 5 here, radical 5, and negative radical 5. Okay, by the way, radical 5 is 2 point something. You put in a calculator, for example, radical 5, square root 5. Square root 5. What is that? 2.23. Radical 5 is approximately 2.23. This is important because I need to have some idea where it's located that, because 2 is located here. 2. Okay? Okay, entonces my mind is, this is crossed. This is also crossed. and zero no, and zero touch. Remember, this is the polynomial graph. This is smooth curve. And never we have a corner like that. This is impossible. Now again, something like that, cross. And this is my end behavior. Any question, guys? Do you understand very well? And behavior, do you understand multiplicity? Do you understand touch and cross? Super clear? Super confusing? Answer me. Clear. Okay. Let's move on to the number 3. Okay, number 3 now. Number 3 is... number 3 is different. Number 3 is find the x intercept and y intercept. This is super easy because you remember the formula. In order to find the y intercept, you evaluate the function in 0. In order to find the x intercept, you take the function, you enforce it to be 0, and you solve in this equation. This is the formula. This is the formula. Okay, now let's move on to number 3. Number 3 says f of x is equal minus x squared paréntesis x plus 9 paréntesis x squared minus 1. Okay, you will in 0 and solve it is 0. 0 squared is 0. 0 multiplied by anything is 0. I don't care. I don't care the sign negative because 0 have no sign. Okay, now the second part is when you enforce it to be 0. It's minus x squared equal minus x squared x plus 9 x squared minus 1. Okay, entonces you apply one more time the zero factor property when the one expression gets factored is equal to 0 is because each factor separately, one by one, is 0. And we connect it by OR. So es minus x squared equal to 0, que es equivalent to say x equals 0. Es obvio que es multiplicity 2, pero es no the point in this. Okay, entonces this is a coincident. And 0, 0,0 is both. It's x intercept and y intercept. But we have more. X plus 9 equal to 0, negative 9. And x squared minus 1 equal to 0. We can factorization if you want, or no necessary factorization. You apply the square root method for solving quadratic equation. X is equal to minus 1. Okay, so basically we have 1, 2, 3, and 4 x intercept. X intercept que was that part, x intercept. And we have only one y intercept. The 0. Okay, conclusion, x intercept is negative 1, 0 is positive 1 is 9. Es 9 o es negative 9. Es negative 9. Negative 1, 0, and 1 is 0. I don't know, guys, but I suppose que es the option B, ¿no? Yes, x intercept is 0, 1, negative 1, negative 9. X igual is option B, ¿no? Let me know if you agree or disagree. Sometimes I don't care that part. The problem is solving well. The rest is not important. Because the test is no multiple choice. The test is you solving well, and that's it. Okay, so you summarize everything in this problem. Y intercept the famous point 0, 0, okay, by the way, is also one X in a set, this point. And the rest of the X in a set are negative 9, 0, negative 1, 0, and positive 1, 0. End story. Question. Question. Super easy. No. Okay, I mean. Okay. Clear. Okay, let's move on to the number 4 question. Number 4 question is similar. Is f of x equal minus x squared parentheses x plus 5 x squared plus 1. And exactly the same. I need to find y in a set and x in a set. For finding y in a set, you evaluate the function always in 0. In this case, 0. That 0, 0 is both. It's x in a set and y. And the x in a set, you take the function, the original function, equal to 0. In our specific example is minus x squared, x plus 5, x squared plus. One more time happen. Minus x squared equal to 0 imply x equals 0 multiplicity 2, but I don't care. The multiplicity, because in this question, don't ask me specifically. I know que multiplicity 2, entonces voy a see I want to do the graph. I know que touch, no cross. And x plus 5 equals 0 is negative 5. And this guy is obvious. Is no solution, right? No solution. So this is totally, completely irreducible quadratic expression. How do you know that? Suppose that you don't know. You don't recognize. Well, I have no idea. I try to solve it like a quadratic equation. Let's say I move 1 to the right-hand side, like a minus 1, apply square root both sides, and you see que the solution is plus or minus I. It's imaginary or complex. That means that in the real field we have no solution. Therefore, this term do not apport any x-intercept. The only real, one important concept that you need to understand. X-intercept is the real 0. We have another 0. Yes, we have another 0 in another dimension in complex, but you don't see graphically in the plane in 2-dimension xy. Okay. Entonces now what is the answer? The answer is the it's big. Okay, let me see. Help me, guys, because I am not good of the selection. Okay, it's big. Negative 5. Negative 1. No. So the only let's see. Hey, putting off microphone. Es sí, Andreina say que es sí. Sí, es negative. A ver, let me see. Negative 5 and 0. Negative 5 and 0. Negative 5 and 0. And why is 0? End the story. Es sí. Yeah, sorry. No, it's okay. It's okay. I like. We are the team. We're discussing, and you help me to understand the situation. Okay, no problem, Bolivar. Remember, you can watch in the video on YouTube. Again, I posted when the class is over. No, not exactly when the class is over, because I have another class after that. Okay. So everyone is clear. So far, we have 100 points in the test. Oh, no. Erase the board. May I? Okay, so far. Alain says, so far, Professor. Okay, Alan. Let's move on to number 5. Number 5. Oh, number 5 is super easy. Number 5 is, okay, we have a polynomial. And this polynomial contains only 2 factors. Remember y and z. Let's evaluate the function n0. And you evaluate n0, we have -3. And -4 is positive 12, no? Okay, entonces the point is 0,12. Is the y-intercept. The x and z, super easy because we have 2 real factors. Is f of x equal to 0. You break it down in 2 pieces. X minus 3 equals 0. X equals 3. Like the order pair is 3,0. And x minus 4 equals to 0. X equals positive 4. 4. Okay, entonces 3 positive, 4 positive, es the y and z, and the x and z, sorry, x and z, and y and z is positive 12. I suppose que es the option C, yes or no? You let me know if I'm making a mistake or not. It's okay, I'm doing right or wrong? Hey, answer me. I select option C, I am correct or incorrect? Correct, okay. Okay, Andrea. Okay, there you go. Correct, yeah, me. Okay. Okay. Number 6. Number 6 is f of x is equal x minus 2 squared and x squared minus 9. Y and z, evaluating 0. We have minus 2 squared times negative 9. This is 4, this is negative 36. Negative 36. Negative 36. And x and z is f of x equals 0. And our specific example is x minus 2 squared, x squared minus 9. The x minus 2 squared equal to 0, that's equivalent to say x minus 2. Now, of course, it's multiplicity 2, no? But it's okay. I don't care that part. Equal to 0, x equal to 2. This is the point 2, 0. This is the x in z. Another x in z, x squared minus 9 equals 0. X squared equals 9. Apply square root both sides or factorization. Either way, like a difference of a square. So x is equal to plus or minus 3. And we have 2 more, is plus or minus 3. The total we have, let me see. Okay, 1 y and a z at the point 0, negative 36. This is the y and a z. And we have 2 x and a z. 2, no? 2, no, 3. 2, 0, minus 3, 0, minus 3, plus or minus 3, 0. So 3, 0, and minus 3, 0. So what option we select correct? I have no idea. I totally lost. I suppose que D, no? ¿Es okay o no? ¿Es D o no? Yes. Okay, align. Align is A. Okay, let's move on to the number 7, que es different. Different flavor. Number 7 is, well, in this case, we have rational functions, and they want to determine the domain. Okay. And remember, suppose rational function, capital R, x plus y over x to the 4th power minus 49. Okay. Well, the first thing you should do always when you face the rational function is express it in factoring form. On the top, stay the same. But the bottom, no. We can factorization using the formula of the difference of a square. It's x squared, and this is 7, and this is 7 plus or minus. And this is irreducible quadratic. Wait. Square root is 7. Okay. And this is irreducible quadratic expression. When it's plus, but when it's minus, no. Let's factor out again. So we have x plus 5. This is still the same because the solution for that part is complex or imaginary, doesn't matter. And we break it down like that. Xx, and this is radical 7 or radical 7. Or another possibility to understand this, okay, is look, this guy never is 0. This guy never is 0. And this guy, yes, is potential 0. And you force it to be 0. And you solve this quadratic equation and you get plus or minus radical 7. But I don't see this answer here. Wow. Sometimes this package have a mistake because it's for power. That we are doing 2 factorization. This part is never 0. This part, yes, possible 0 in radical 7, no? Radical 7. When you blew that radical 7 here, radical 7 to the 4th power minus 49. This is 0, no? Because square root x is 7 1/2 raised to the 4th power minus 49. 1/2 times 4 is 2. 7 squared minus 49 is 0. And 49 minus 49 is 0. So the bad guy, to be undefined, this function is in radical 7. You of course negative radical 7 because that part of the function is even. So it doesn't matter the sign, it's symmetric. That part, the bottom part, top no. And the title, of course. Okay, so our packet have a mistake, no? Our packet have a mistake. What is the domain? Well, the domain is, let me express it like that. They want you to express it in this way. The x such that x no equal radical 7, comma, x no equal minus radical 7, and that's it, no? And that's it. Okay? Do you understand que the packet have mistake or no? How would you write in the exam? No. Okay, in the exam. The exam is no multiple choice, sir. That in the exam, you have a question, and you have one space in blank. Can you fill out with the answer? Therefore, we have no choice to select. And so you are doing well, you write well, and that's it. No, this is this packet created for the teacher. No, so a teacher maybe one mistake in 1 million of the example is good rate. No, it's good score. Thank you. No problem. We are human. Remember, we are human. I understand any situation. Okay, I try to solving any problem. I try. Sometimes it's impossible, no? But sometimes, yeah. Okay, does any question number 7? It's clear. We're doing well today. Well, of course, this is the easy part. Let's see after that. Let's move on to the number 8. Number 8. Number 8. Number 8. Number 8 is G, capital G, of X equal X plus 4 on the top over X squared plus 9 in the bottom. Wow. What do you think, guy? What do you think? How you investigate domain of any rational function? Well, you take the expression in the denominator. I don't care the expression in the numerator. Vance amazing say, all real number, professor, because this is a reducible quadratic. So when you try, suppose que you don't know, because I try to investigate this, or you try to investigate this without knowing. Yeah, I realize this is imaginary, right? The potential restriction is completely out the all real number line. Therefore, the domain is all real number. Entonces, they select option D, all real number in English, all real number, all real number. Well, si do not indicate the way that they want to express the answer, you write either way, in English, in interval notation, or I don't know, another notation is like that. This is the option D, no? This is the option. Right. Everyone follow me? Okay, it's classical, guy, in algebra. In algebra, when you try to find something, okay, I set out the equation. But when I solve the equation and the answer is complex or imaginary, it's because the thing that you try to find do not exist. In this case, the thing you try to find is the potential restriction. We have no potential restriction, at least in the real field. Therefore, the agreement is that the domain is all real number except the restriction. And the restriction living in another dimension, therefore, in the real number, we have no restriction. Okay, number 9. Number 9 is Q of X equal X plus 9 divided by X squared minus 49X. Okay, you take this polynomial in the bottom, you enforce it to be 0, and this give me the restriction. Let's do the factorization. The great common factor is X. Therefore, X equals 0 is my first restriction, and X equals 49 is my second restriction. Okay, the domain is all real number, except this bad guy. No 0 bad guy. And so you can separate by a comma, okay, by the way, it's equivalent to say and comma is saying it's perfect understandable and not 49. Okay, la que de option A, ¿no? Es option A. Okay, super. Clear, guy? This part is easy. Okay. Let's move on to number 10, que is the last problem of this part, domain, rational function. Okay, 10. 10. Is 2. The name is capital F. 2x squared minus 4 divided by 3x squared plus 6x minus 45. You take this expression, the denominator expression, get the potential restriction. You need to avoid 45 to be 0. 45. I can see that the great common factor is 3. I factor out 3, and we have x squared plus 2x minus 15. No? Because I ignore totally this. Because this 3 never is 0, no? But the responsibility to be 0 is this expression. And this expression is trinomial, the regular trinomial. And you factorization, the super easy way, xx. 5 and 3. No? 5 times 3 is 15. And somehow 5 minus 3 is positive 5 and negative 3 equals. Now, x plus 5 is equal to 0. Therefore, x is negative 5. And x minus 3 equal to 0. X equal positive. Now, the domain of this expression is all real number except positive 3 and negative 5, like the option C. You write like that. X such that x not equal negative 5, comma 1, whatever you want to write, x not 3, positive. In the story, option C. Any question? Okay. Are you boring? Everything is easy so far? Okay. Okay, let's move on to the graph of the making sense so far. Okay. I understand. Making sense so far. 11. What's the idea for 11? Graph the function. Well, it's x minus 1 over x. By the way, guys, I create in Desmos the majority of graph of this package. I want to share with you this. When the class is over, why not? I send the link connecting with my Desmos. Okay, do the graph. Not all questions, but the questions that I consider important. No? Because at this saves time. You practice, you try to do by yourself, no? But no. They tell you are doing by yourself. Okay, this is typical rational. It's not clear, but it's typical rational. Regular rational is the division polynomial divided by polynomial, no? Well, in this case, if you condense this, the least common denominator is x squared minus 1, no? It's another way to see that. Equivalent, algebraically. However, remember, to start a problem, I need always the factorial form. And the factorial form, in this case, in the top I can see is the difference of the square. And the factorization is x plus 1, x minus 1 over x. Okay. Entonces, well, either way, this is more comfortable working with this. But sometimes it's comfortable use it that way. Either way. Okay, remember we have a 7 step to do the graph perfectly of the rational function. Number 1 step is factorization and delete or cancel out the factor that is common because this factor is a whole. In this case, no. In this case, we have no whole. Okay, perfect. This is step 1. Step 2 is determine the y-intercept and x-intercept. Remember the formula? The formula for the y-intercept is evaluate 0. But it's obvious that in that case it's undefined because you evaluate here in 0 or you evaluate here in 0. Okay, again, it's the same stupid thing, no? It's undefined. Defined. It's undefined is because the y-intercept I try to find do not exist. There's another possibility, no? It's undefined for two reasons. Because it's the division by 0 or it's imaginary complex. But it's the same idea, it's undefined. However, the x-intercept is easy. You take the function, you enforce it to be 0. And remember, when you have a fraction, the responsibility to be 0 have the top part. Yeah, ignore, totally ignore the bottom part. For me, this is not important now. Okay? Entonces es obvio que es x plus 1 equal to 0, x equal minus 1, and x minus 1 equal to 0, x equal positive 1. But we discover that this graph have no y-intercept, however, contain two x-intercept, a negative 1, 0 and a positive 1, 0. Wow, it's raining here. Okay, one more step, important. Vertical asymptote. Vertical asymptote. Vertical asymptote is you take the polynomial in the bottom, que es just x, equal to. And that's it. After the simplification, the potential holds. We have no hole, okay? Super. So, in that moment, I like so much try to do by hand. And after with verification of decimal, right? Okay, we have all resources to do that. This is my famous all real number x. I plot the vertical asymptote is at 0, this is 0, x equals 0. And we have 2 points, 2 famous points, 1, 0 and negative 1. This is the situation that we have so far. This is the situation that we have so far. What is the step 4? What is the step 4? Always. It's the famous step 4. Could you help me or no? You don't remember or you remember? If you don't remember, no problem, because I'm here to refresh your memory. Okay, es determine the horizontal asymptote or slant asymptote. What do you think about that? Remember, it's analysis of the degree. Degree at the top, degree at the bottom. What is the degree of the polynomial at the top? What is the degree of the polynomial at the top? 2. And what is the degree of the polynomial at the bottom? And when this situation happens, what do you think? We have horizontal asymptote, yes or no? We have horizontal asymptote, yes or no? René. Alain René dice, we have horizontal asymptote, yes or no? No. No, we have no. We have no. We have a slant. Correct. We have a slant. We have a slant. We have a slant. And to find the equation for the slant, we are doing the division. But actually, I am doing in the original expression. Okay, let me copy. I copy that. Y equal, or f of x, it doesn't matter. X minus 1 over x, no? And that part represents the slant. Because the thing we are doing is perform a division, no? But in this case, given in that way. So it's super clear que the slang asymptote equation is y equals x. I am doing that line. It's the slang y equals x. Okay. Okay, super. Okay. What is the step? Step 5. Step 5. Step 5. No, wait. Well, I need to check in. Well, no. In this case, impossible. I need to check in if my graphic cross or no the slang acid. Pero I suppose it's impossible because look at that. Okay, you have x minus 1 over x equal x. Now, I put the equation for the original. I put the equation for the slang, put together each other. This part is canceled. So 1 over x equals 0. And this, we have no solution. In conclusion, the curve, when they are doing the curve never cross the slang. Never. Okay, let me test in the symmetry. Just thinking. Step 4. Step 5. It's the symmetry. So I make a reflection and let's see what happens. I have no idea. Suppose I taking no necessarily the original. I can do that. The original. Oh, I prefer in that way. I prefer in that way. So either way, but I prefer that way. I don't know why. Okay, suppose f of x, the original f of x is equal x squared minus 1 over x. Okay. Yeah, I make a reflection. It says minus x squared minus 1 over minus. This is a square. Doesn't change. And 1 over minus x. This change. And this minus that we have here. Wow. I can put it in front like that. X squared minus 1. And we compare this new after the reflection and the original. What do you think? I get it hard to hear over the rain. Okay. Let me see, because I suppose there's no. Well, okay. Let me switch the place. Think about that. What do you think is even if odd or is neither? No symmetry. Guys, I have some problem. Neither. No. Because I have no physical copy of the review back. I have electronic. I can see in another computer. No? Yeah, I can move the laptop, but I cannot move the computer. Maybe I can print now, but no. Okay, I see the sky, and this is not too much rain. It's supposed to decreasing right now. Okay, let's continue analyze. If you want, I speak loudly. You see, wow, look at that. When you replace x for negative x, and you get completely opposite sign in the expression, this is odd function. In this case, it's minus. Now this is exactly the same twin brother, but opposite sign. It's obvious it's odd. I suppose, well, I have no idea. The last step is try to try to select the different point and evaluate the function. Okay, of course, we are not doing by hand that part. I recommend that you go to the Desmos. I have here Desmos. Let me switch into Desmos. Wow. Who changed the background? Come on, fix it, that background, please. Okay, there you go. Okay. Do you see Desmos? Yes or no? Good. This is question 11. Look at that. Bang, bang, bam, bam, bam. Look, question 11. What thing you can see? You can see the original function. You can see the slant asymptote. You can see the vertical asymptote. And you can see the x intercept. If you want, I plot different extra points. This is the homework for you. Okay, I have some idea perfectly how it look like. What option you select, guys? What option you select? A, B, C, or D? What do you think? A, of course, Andreina. Any question? What part is confusing? Any question? Stop raining now. Let me come back to the whiteboard. Whiteboard. Switching to whiteboard. Whiteboard. Okay, there you go. Whiteboard now. You have no question about the 11 question? No? No? Okay, let's move on to 12. 12. It's the same question. Do the graph. Rational function. I thought that the equation would be odd because x squared. This is good. Okay. X squared minus 1 over x. It's obvious that when you replace here negative x, stay the same because this is square. That part only, see, I analyze the top part only, is even. However, when you bring in negative here, it's negative because this part is up. And even and odd together is odd. Si es even and even, it's even. Pero si es even and odd combination, doesn't matter si it's the top or the bottom. It's eso. Do you understand very well or no? And you can see, okay, I make it more sense. Okay, no, this is a review. And you feel free, don't hesitate to ask me any question. Okay, because my intention is training to you, que you be strong to destroy my test. I promise that the test is no piece okay, it's hard. Everything is hard with me, everything. Okay, number 12. Number 12 is f of x is equal x over x squared minus 16. By the way, let me see. Intuition again. Let me skip a step. So you want to prove that this function is even, is odd, or is neither. What do you think? Using the common sense and imagination. What do you think? Even, odd, or neither? Huh? So we're doing the step 7. Huh? It's odd. It's obvious it's odd. Because that part is even. Doesn't change if you replace x for negative x, but this yes. See, at least one change, therefore, is negative. It doesn't matter que negative in the top, positive in the bottom is negative fraction, because this negative you put in the front. No? You put positive divided by positive, it's the same, right? Okay, super. Okay, little by little, you get intuition about it. And English, wow, very difficult. Wow, I am teaching another class after that. It's 10:33. And the students are horrible. I enjoy teaching with you. Okay. What is the first step? I'm totally lost. Step 1 or step 0? What is the step 0 to start? Factorization. F of x is equal to x over. This is different of a square. X over 4 plus or minus. We have some common factor that we can cancel out something or no? No? No whole. No whole. Okay. In the case that we cancel out, so this is a whole. The factor is gone. It's a whole. Okay. Now y-intercept. Evaluate the function is 0. It's obvious it's 0, no? 0 on the top. I don't care the bottom is 0. 0, 0 is both. It's x-intercept and y-intercept. And x-intercept is f of x equals 0. Okay, it's equivalent to say the top part equal to 0. Conclusion, we have only one intercept. It's 0, 0 the origin. It's both. It's x-intercept and y-intercept. By the way, and the step, what is step? Step 6, no? We discovered it's odd function. Yes or no? We did that. Okay, what is the step? This is step 1. I put 0 to emphasize the first thing. Step 2 is the intercept. Step 3 is the vertical, no? And we have vertical, yes or no? What is the formula to find the vertical? The formula is q of x equals to 0. And who is q? The polynomial at the bottom, this guy. Or this guy, doesn't matter. I suppose que es x plus 4, x minus 4 is obvious. Apply zero factor property, que es plus or minus 4. Es x equal positive 4, x equal minus 4. We have two verticals. So in this moment, I like so much to do by hand to have roughly idea my graph. My graph contains one point que es 0,0. 0,0 is also x-intercept and y-intercept both. And we have in 4 in negative 4. 1, 2, 3, 4. 1, 2, 3, 4. 2 vertical. And also I know que es odd. Si es odd, is symmetric. We respect the origin. I don't know if it's like that or like that, like that, like that. After I can see plot different point, no? Or doing this. Vertical number 1, vertical number 2. So far, everyone follow me or no? Step 4, no? Step 4. I follow. Okay. Step 4. Very well. Step 4, no? Horizontal or slant. Randy dice yeah. ¿Es yeah o es yes, Randy? What do you think about horizontal and slant? I need help because I don't remember very well this. Come on. Help me with the slant and horizontal. Remember, it's analysis of the degree. Degree analysis. Degree analysis. Okay. Let me copy. I don't know if I want to copy the original or I want to copy the factor form. I don't know. Top degree A1. Top degree A1, degree A1. And bottom degree S2. Very well. It's the analysis of the degree. When this situation happens, we have horizontal or no. or we have a slant? I don't remember. And horizontal, we have a special or regular. Yeah, what value? Answer me. You remember or you don't remember? Okay, we have horizontal in two situations. When the degree is the same, or, que es the regular, or when the degree of the denominator, que es 2, is bigger than the degree of the numerator. Entonces, this is horizontal, pero es special. And special is always at y0. Okay, entonces we have here one horizontal asymptote. And by the way, the point que the horizontal asymptote, special case. Very well. Special case. Horizontal asymptote. And by the way, the famous point in which the curve crossed the horizontal asymptote is 0, 0. 0,0 is everything. It's y in a set, it's x in a set, and also it's a special point in which the horizontal asymptote, the curve crossed the horizontal asymptote. Okay. And of course, land we have no. It's obvious, right? Because this is mutually exclusive. So you have horizontal, we have no slants. We have a slant, we have no horizontal. Entonces, in the step 5, we determine que es odd function. Now the rest is plot the point. But to save time, I want to do in decimal, no? Okay, I switch into decimal. Okay. Do you see decimal? Question 12. Bang. Align, look at that. This is the original. I put in red color. I don't know why. This is the famous 0,0 point. We have the vertical asymptote in +4 and -4. We have horizontal in y0. End the story. Any question? So you select what option you select in the handout. And you select option B, I guess so, no? Option B, right? Option B. And do you see, look in the graph. Let me make a zoom. Do you see the function is odd function or no? What is the definition of the odd function? Definition is one value, totally arbitrary. Suppose que I evaluate in 4. Let's do it by curiosity here. Look. Okay, suppose. Let me include a point. Suppose que I have, well, okay, to make easy, my recommendation is, this is a good idea. Instead of y, you put f of x using function notation. It's the same. Y and f of x is the same. But function notation give me the advantage. Okay, I type the point, for example, 4. I type it 4, que es the totally arbitrary value of the domain que I select. I don't know why. Comma, f evaluating 4. Okay, y I put the label. Sorry. No 4. Carajo. Let me select another 2. Horizon defined. I suppose que F I using in another problem. Okay. Let me using where W. Okay. Entonces W here. Ah, carajo. The problem was, well, okay, W. W. Well, this is 2 comma W. Let's put 4. Bang. I don't care. It's decimal. It's negative, right? Likewise, si I select negative 2 to illustrate que es odd function very, very well, separate by comma another point que es negative 2, negative 2, negative 2, comma, W, que is the name que I put for the function, evaluate negative 2. Boom. Look at that. In positive 2, the answer was negative 0.167. In negative 2, the answer was exactly the same value, but opposite sign. This is a typical example of the odd function. Asymmetry with respect to the origin. Good, clear, or confusing? Do you understand very well odd function? And we can use in, I want to illustrate this idea because we can use in decimals to evaluate. I'm not necessarily doing by calculator. So you using the function notation, you take advantage function notation. Okay, let's come back to the whiteboard. 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 Whiteboard now. Boom. Okay. Okay. So move on to number 13. 13 now. 13. 13 is f of x is equal x squared plus x minus 6 over x squared minus x minus 2. Well, the first thing you should do is factorization. Factorization de polynomial at the top. Factorization de polynomial at the bottom. 1, 2, 3, and 4x. Okay, the combination in the top is 3 and 2. 3 times 2 is 6, and 3 minus 2 is 1. What is a positive? And it's a negative. And the bottom is 2 and 1. Because 2 times 1 is 2. And somehow 2 minus 1 is 1. And minus here and plus here. And you can see, wow, this and this say goodbye. Cancel out. Now, we have x plus 3 divided by x plus 2. Entonces, this expression and this expression are equivalent almost 100%, except at x equal 2, because in 2 we have a famous form. Got it? So when you are doing the graph of this, I suppose que in 2 you put a hole. Okay, do you understand this or no? Okay, now this complete statement now is equivalent 100% of this. So you include the whole. Okay, but this is the practical way is you do the graph of this, que es easier. And the graph of this is equivalent, except in 2 we have a whole. Okay, so we focus it in this part. What is the next step? Well, the next step, y in z, x in z. When y in z is evaluado en 0, y cuando you evalúo en 0 es 3. Es the point 0,3. X in z is f of x equals 0. That you take the top part equal to 0. Es obvio que the solution is negative. And negative 3,0, we have the only one x in z. Only one. Only one, yeah, the negative. Okay, super. What's the next step? Vertical asymptote. Vertical asymptote, the formula is cube x equals 0. And qx is the polynomial in the bottom after the simplification. Okay, es the value que es completely out of the domain, pero stay alive after the simplification. Because we have two undefined. One undefined in positive 2, que es a whole, and another undefined in negative 1. Okay, at x equal negative 1, we have a whole. A whole, no, sorry. Vertical asymptote. A whole in 2. Okay, so in this moment, let me try to start a little bit the roughly sketch. The roughly sketch x, we have in 0,3, but this is y-axis. Okay, y-axis, y-axis. 1, 2, 3. We have the y and the z. Yes, this guy. And negative 3, and negative 1, negative 2, negative 3. We have 0,3. This is negative 3. Okay, so, but we have also a negative 1 here. The vertical asymptote. And also we have a hole in 2. In 2 we have a hole. I don't know exactly where, but we have a hole. So see, I don't know what is the y value. For the moment, it's not much better to do that. Okay. Now, what is the next step? The next step is the horizontal. Horizontal asymptote and slant asymptote. Or slant, because it's mutually exclusive. In this case, it's the analysis of the degree. What do you think? Help me with the discover this idea. We have horizontal, yes or no? At what value? Normal horizontal. At what value? Normal horizontal. At what value? Y equals something. Degree 2 both. Okay, perfect. And the original. And the new one after the simplification is degree 1, degree 1. The same idea. Degree 2, degree 2, degree 2. Es a 1. Es a 1. Okay, I try. Okay, so I'm doing that. One horizontal. I do in one horizontal. Horizontal. Always, okay, I have horizontal or slant, I try to investigate if the curve crosses or not the horizontal. Therefore, I take no the original. I take the simplified way, que is x plus 3 over x plus 1. We can do them both, no? And enforce it to be equal 1. Investigate si one value of the x satisfies this equation or not. Es obvio que no, no? Because you apply cross multiplication, x plus 3 is equal to x plus 1. This is a contradiction. You don't see it's a contradiction. I try to continue. X minus x equal 1 minus 3. This is 0. X, que es 0, equal minus 2. This is totally contradiction. That means that this equation have no solution. In other words, the how do you do the horizontal again? Because in the second part of the game, we need to investigate if the curve crosses or no the horizontal. Okay? Always. Don't forget this step. The student frequently forgot this step. Entonces you set up this equation in which you suppose, hypothetically, que the curve, que es this equation in the simplified way, is equal to 1. But I get no solution. That means that the curve never crosses. Okay? Never crosses. Do you understand or no? Make sense or no? Okay, let's do it now, the test of symmetry. Understand? Okay. Test of symmetry. Test of symmetry. Remember, you replace X for negative X. Your investigation is odd, even, or not. What do you think? Help me. I need help to understand this. You apply the test of symmetry in the original, or in the new one? What do you think? In the original, or in the new one? After the simplification of the whole. And the original, we can, but what is the reason that we cannot apply in the simplify? You can. Remember, they are perfect equivalent except in the whole, and the rest is okay. So in my opinion, no, we are doing both. But in my opinion, it's easy. And let's do it in both. Let's do it in both. Okay. Suppose that I replay here in the original. I take the original. Entonces, the original is minus x squared plus minus x minus 6 over minus x squared minus x minus 2. Another student doing in the simplest way, minus x plus 3 over minus x plus 1. Okay. Suppose the student select the original, realize okay, this is stay the same, this no, and this stay the same, and this stay the same, this no, and this stay the same. Let me copy the original. The original was x squared plus x minus 6 over x squared minus x minus 2. No? This is the original. All this compare with this. It's the same. What do you think? Even, odd, or neither? What do you think? Even. I don't think so. It's completely different. Okay. Even is when you replace x for negative x, and the new function is twin brother. Twin brother means exactly the same. No opposite sign, no. And you can see, for example, in the easy way, in my opinion, the best way to do is using this. When you change x for negative x, this expression is completely different to this. Therefore, it's needed. And regular happen if we have combination square and linear and constant, because this guy alone is even. This guy alone is odd. This guy alone is even, no? Because it's 6, because it's a constant function. And remember, the even is the function that is symmetric with respect to the y-axis. And the odd is the function that is symmetric with respect to the origin. And the combination, the crazy combination, give me neither. It's clear or confusing? Come on. Clear or confusing? Clear or confusing? Okay. Entonces the rest now is do the graph. You select arbitrary point, plot the point into the region or into the simplified form, and do the graph. Okay, this is the question. What number is that question? I don't remember. 13. 13 question. Okay, I switch into this one now, guys. Switching to this one. Switching to this one. Switching to this one. Here, over there. Okay, this one. Okay, question 13. Look at that. And this, I put the original. I put the vertical asymptote and -1, horizontal asymptote and 1. You can see the the famous point. Negative 3,0 is the x in a set, and 0,3 is the y in a set. I plot, well, I plot some point, I don't know. The hole, the famous hole, look at that. The famous hole that we are doing, okay. How you find the famous hole? Well, the position, the location. Okay, suppose I plot in another line the function, okay, y equal, after the simplification, okay, the simplification was, let me come back to the x plus 3. I want to copy one piece of paper over x plus 1. Okay. I come back to Desmos. Okay, this is Desmos. You see Desmos? The thing I try to do is I copy, I copy, parentheses. Let me use on the keyboard for this. Parentheses. X plus 3. Close the parentheses. Division, not necessarily parentheses now. X plus 1. To emphasize the idea, I want to change the color because blue is not good. I change to red. Okay. The red color is the graph of the simplified, and the blue color is the original. And the only differences in between these guys is a hole. These have no hole because I delete. And the original, yes. And so you type in here the point, que es 2, something. How you find the something? 1 or 2, you evaluate 2 and this. 2 plus 3 is 5. And 2 plus 1 is 3. Es 5 over 3. Es the point que corresponde in the simplify. However, I know que in the original is 2, undefined. 2, undefined. Okay? Do you follow me? Do you understand what I try to explain? So the position for the whole, I cannot get substitution in the original because when you evaluate in 2, the y value is undefined. However, after the elimination of the whole, I can plug it in. But I know that this is not the original. This is the simplified form. ¿Es confusing or is clear? Confusing or clear? Let me come back to the whiteboard. Okay? Kind of confusing. Okay. Let me try. Okay. We come back. Do you see the whiteboard? Oh. Okay, align. Who said get confusing? Who said get confusing? Yasmin dice que no es clear. Who said get confusing? Come on. Yasmin. Okay, Yasmin, look. Look at Yasmin. Okay, the graph of this and the graph of this are identical. The only thing I used in here was blue color, and here I using red color. Well, unfortunately, I have no red color. I have another color like that. Yeah, it's approximate. But the graph of this have no hole. However, the graph of this have hole. Hole where? In 2, at x equal 2. And how do you know the y value? Well, the y value is undefined because it's a hole, no? But see, I want to find the location in Desmos using a circle open, okay? You evaluate in the simplify 2, and when you plug it into here, 2 and 2, 2 plus 3 is 5, and 2 plus 1 is 3. And this famous point gets a whole is 2,503. More clear, Yasmin, now? More clear? Excellent. This is what option you select, A, B, C, D. Well, it's easy because the only option that have a hole is D, no? Do you see the hole in the multiple choice? And you see we have the Baker asymptote and at -1, and horizontal asymptote in +1. And the x-intercept is -3 and the y-intercept is +3. Super. We are the best in Miami-Dade College. Any question? Any question? Okay, one more. 14 is the last one of this kind. Yeah, because we go to another topic. Okay. 14 now. 14 now. 14 now. Okay. The function is f of x equal x minus 3 squared. And the top we have x squared plus 5x plus 6. Okay, the step 0, the first thing you should do always is factorization. The f of x is factor for x. Well, this stays the same, but this no. The combination is 3 and 2, no? But it's positive. And we have no common factor to simplification, therefore we have no hole. No hole, no hole, no hole, no hole. So we have hole only when you delete one factor. After that, y-intercept, x-intercept. Y-intercept, evaluate the function as 0. When you evaluate 0, on the top we have 6. And the bottom we have 9, I suppose. It's 0 minus 3 minus 3 minus 3 squared 9. And reducing lowest term, 2 terms. Okay, it's 0, 2 terms. Or if you want to express it in decimal approximation, is 0.6 repeated. This is y-intercept. Okay, good. Now, the x-intercept is when the f of x is 0. Or equivalent to say the top bar, x plus 3, x plus 2 equal. You derivate two equations, two linear equations. Plus 3 equals 0, negative 3. Plus 2 equals 0, negative 3. We discover 2x-intercept at the point, negative 3, 0 and negative 2, 0. We finish the step 2. Okay, it's basically y-intercept and x-intercept. Let's go to step number 3, gets the vertical asymptote. Vertical asymptote, you take the polynomial in the bottom, equal to 0. Polynomial in the bottom is x minus 3 squared. In this case, actually, we have only one factor because it's repeated. Okay, maybe you find the solution is you take x minus 3 without square equal to 0, no? You know que es multiplicity too, but I don't care the multiplicity in this example. Okay, entonces basically x equal 3. In x equal 3, we have the vertical asymptote. Okay, horizontal. Horizontal or slant? Well, we see. Well, degree of the polynomial at the top is 2. Degree of the polynomial at the bottom is 2. Same degree. That's what we have. Yes, we have regular, normal, whatever you want to call normal or regular. horizontal. At the point y equals something. Y equal what? Y equal, okay, the end behavior expression. In the top is x squared. And end behavior expression of the bottom is x squared also, right? Because you remove mentally these three. Entonces, one. One. Okay, now I try to investigate if the curve crosses or not the horizontal axis. Okay, let me try. You copy? You copy x squared. You copy the original factory form either way, plus 5x plus 6 over x minus 3 squared equal 1. You enforce it. Surprise, maybe we have solution or maybe we have no solution. Actually, it's equivalent to say x squared plus 5x plus 6 is equal x minus 3 squared. When you expand this, it's x squared minus 6x plus 9. Well, it's obvious that that part is say goodbye, cancel out. We have 5x plus 6x equal 9 minus 6. I solve this linear equation. It's 11x equal 3. Divided by 11 both sides. Okay, at x equal 3 over 11 is the famous point in which the curve crosses this horizontal. Okay, by the way, is the point 3, 11, 1, because it's the same y value. Okay, very well. Testing a symmetry. What do you think about the symmetry using the common sense and your imagination? Look in this. Look in the original. What do you think is odd, is even, or is neither? Using common sense and imagination, no algebra. Are you tired? Even, no. Es obvio. Okay, si you analyze one by one, it's neither, of course. Align. Look. Suppose this expression es obvio que sí. This expression alone es obvio que sí. This expression alone es obvio que sí. Because it's a constant. Pero this expression is odd. And their combination, when it's multiplication, maybe is odd. But when it's addition or subtraction, it's neither. Okay. Okay. The strictly way to prove that is replace x for negative x. When you replace x for negative x, well, let's do it. This stay the same. This no. This stay the same. Only one guy can fail. Yeah, it's not possible to be even. And this is minus x minus 3. Oh, this changed also. This is f minus x is equal. In the top, x squared minus 5x plus 6. In the bottom, this negative and negative together, square become positive. So actually, it's x plus 3. Wow, do you see that? Okay, you consider in your mind, okay, this negative and this negative, you factor out like a negative 1. And negative 1 squared positive 1. And positive 1 is invisible. Okay, now we compare this and this, totally different. It's all because neither. Okay? Let's move on to Desmos to see the graph. Let's move on to Desmos to see the graph. Okay, let me share Desmos. Switching to Desmos. Okay, there you go. Okay, I suppose you see Desmos, right? We're doing number 14. Bang. Look at that. Number 14. Number 14. Okay, I copy the original. Okay. I found. Okay, I found the let me see. Okay, 4 point. What is the typical 4 point? This is the y-intercept. Okay, but by the way, it's this 0.2 positive. We found two x-intercept, is negative 2.0 and negative 3.0. This and this. And we found also the super important point is the point when the curve crosses the horizontal axis, okay, it's 3/11,1. And also we have the vertical. In this case, the vertical is positive in both directions, and the reason it's positive in both directions, the interpretation of this is because it's a square. When it's a square y es positive, it's because it's in both directions. Si es linear, no. Pero si es a square, it's positive in both directions. Any question? So what option you select? What option you select? What option you select? I suppose you select C, no? Yes or no? I suppose we select C. Okay, super. Any question, guys? We have 10 minutes more. No. Okay, good. Very good. Very good, Jasmine. Okay. Okay. Let's move on to another kind of questions. Is inequality. Polynomial inequality. Okay, polynomial inequality. Suppose this inequality is equation 15, 1, 5. X to the 4 power less than 9 x to the 7. Okay, what should I do? Remember, you manipulate the inequality in order to express the right hand side 0. This is a super important moment. X to the 4 power minus 9 x to the 2nd power less than 6. And you, sorry, still in Desmos, Andre. Okay. I try to explain question 15. Question 15, I copied the original. After that, I move 9x squared to the left because right hand side must be 0. This is the idea for solving any non-linear or polynomial inequality. Now factorization. The greater common factor in this expression is x squared. Factor out x squared. We have x squared minus 9. Now a difference of a square. X squared. You break it down in 2 factor. X 3 plus or minus. Okay, ready. This is now my new inequality. Okay, by the way, is equivalent to the original. And also it's easier to understand. Okay. Everyone follow me? Everyone understand this idea? Okay. I have a question. I have a question. Good. I have a question. The question is, we can delete this guy or no? We can delete or no? Remember, I explained que the factor que contain exponents even, we can sometimes delete partial or delete totally. In this case, delete or no, partial or totally, or I don't know. Yes, what means yes? Delete, pero totally or partial? Totally or partial? Partial, very well. And what means to be partial? Delete. Well, que this inequality is equivalent. You mentally forgot temporarily this guy, and you copy only x plus 3, x minus 3, less than 0. And finally, why not? And you include no 0. Because in 0 we have to hold. So, for sure, I guarantee you 100% that this statement and this statement is the same thing. What is the practical thing? Well, the practical thing is that you forgot temporarily, of course, that part. We focus in the inequality part. We solving that. And after you know that the final answer contains whole and 0. Okay? So my recommendation is ignore for a moment that part. Well, you keep in mind, no? But ignore. And you copy this inequality. Wow. It's extremely easy inequality. Entonces, what method you recommend me to do? The classical or the change of sign? Or the change of sign? I recommend, well, I like so much change of sign. Entonces, now, change of sign, remember you find the critical value. You convert temporary to equation. I solve this equation, the answer is positive 3 and negative 3. And this is my critical value. Okay, using to make it a partition. The partition of the all real number line. Okay, positive 3, this is 0 in the middle, 1, 2, 3, and negative 3, 1, 2, negative. Super. Okay, now you select testing point. For example, not 0 because I know that 0 is a whole. So now you select negative 4. You select another guy inside here, positive 1, maybe it's good, and 4. And it's a potential testing point. The testing point helped me to analyze only the inequality part. So now we have negative 4. We have positive 1 or negative 1, whatever you want to select inside, in between negative 3 and positive 3, and positive 4. And the factor involved in my problem is x plus 3, x minus 3. I put a total column. Okay, this is negative, this is negative, this is positive. This is positive, this is negative, this is negative. And 4 is positive and positive. Okay, now I come back at the beginning. My inequality is less than 0. Look at that. My inequality is less than 0. And less than 0 is equivalent to, say, negative. The sign negative is true. Like that. And the only guy that is negative is that. True. True here. Because the interval belongs to the 1. So basically, the solution of our inequality is like that. But don't forget, in 0 we have a hole. In this case, put like a yellow hole. So what is my final answer? My final answer is this interval. Okay, of course, es paréntesis, ¿no? Paréntesis, paréntesis, ¿no? Paréntesis, keep going here to 3. The final answer in interval notation expression is from -3 to 0. The final answer is from -3 to 0. No 0. 0 is completely outside the game. And union, or whatever you want, union from 0 to 3. Okay, I suppose que es the option B, no? Option B. In the handout. Any question? What part you don't understand very well? Okay, it's important that you understand the manipulation for this kind of inequality. Number 1 step is right-hand side must be 0. Factorization. The factor que contain exponent even, you must delete. Partial or totally, depending si es equal or no equal, the inequality. Si es no equal, like this case is partial. Si es equal, it's totally delete. Okay? Now you focusing on the rest of the inequality and you apply the method you know. Changing sign. Okay. Any question? Okay. I propose doing one more, and that's it. You have no question? No? No? Are you tired? This is intensive class. No? Okay, super. Remember, I tried to finish early because I have another class. I need to prepare the thing for another class. But 16, let's do it quickly, 16. 16 is easy. It's x to the 4th power minus 21 x to the 2nd power minus 100. Put it answer. Okay. Okay, right hand side 0. Okay, I like that. Now factorization. We focus on the factorization. Factorization is x squared, is the square root of this guy. And the combination is 25 and 4, no? 25 and 4, multiplication is 100, and 25 minus 4 is 21, and this is minus, but this is plus. Now I finish the factorization? No. I need to apply difference of a square here. This is x 5 plus or minus x squared plus 4. Okay, and this is my new inequality. I focus in this. Okay. However, I have one guy I need to analyze. Get this guy. This guy is totally delete or partial delete. Totally delete or partial delete. What do you think? Is totally delete or is partial delete? This guy. Partial delete. No. Let me explain why no. Okay. It's no equal that idea. Look at that. So you have x minus or plus 4 squared, and we have x squared plus 4. Okay. The graph of this is a parabola. The graph of this is also parabola. But the graph of this is a parabola again, -4 here. It's something like that. That is a reason because you have no equal sign, you delete that part. However, x squared plus 4 is completely different parabola. It's a parabola like that. It's like a vertical shift. And this parabola is always positive. And this parabola is always positive. Entonces, si this is always positive and never is 0, you can totally delete. Yes or no? Never this is 0. Never this is 0. Entonces, totally. Be careful. This kind of expression and this kind of expression. Do you understand or no? Do you understand or no? I still confusing. Okay, I understand. Okay. Look, I agree with me. Okay. I suppose that you remember that in one inequality, the positive guy do not participate in the game. Only participate in the game the negative guy. You count how many negative we have. Well, we have 3 negative, 4 negative. But the positive bar is completely irrelevant. Same situation happen. This expression is always positive. Now it's totally irrelevant. Like that. This no. Why no? Because depending si my inequality is greater than or equal. Si it's greater than or equal, we can delete totally. Okay, because it's this positive, this parabola is positive or 0. However, si it's greater than, what happened in -4? In -4, when you plug in here -4, -4 and +4 is 0. 0 squared is 0, and 0 never is greater than 0. Okay, this kind of expression is different to this kind of expression. This, it's always positive. Very well, mister. And you totally delete. Boom, boom. And it's not, you be careful. Sometimes delete partial and sometimes no. The dependency is greater than or equal, totally, or no equal partial. Make sense? Okay, my recommendation is stop because I need to prepare another class. Stop, we continue this problem again, next class, and we continue the rest. I want to send the video of this plus the link que connecting with Desmond. You can see my work. And when you share my work, you can modification something because it's just your work. But I want to say when the class is over, no exactly 1 p.m. today. I want to send the YouTube video for today plus Desmond. The Desmond included the majority of the graph that we have in the review. Okay, guys, recommendation study for the test number 2. I don't know, so you see hard or not, but my experience is it's hard for the student. Okay,